Now let's take a look at how we can write the Gaussian elimination method as an algorithm in Octave. So we are trying to eliminate these variables here. So here are the formulas that we use to eliminate these coefficients, right? So R2, row 2, uses row 1 divided by this coefficient 3 multiplied by the opposite, and then we add to row 2. Notice that this number here is a constant, or it's a number that we multiply the entire row 1. That number, so if you look at this negative 2, this is basically the coefficient or the entry of the matrix A 2, 1. And this guy here is A 1, 1. So A 1, 1 is the very first coefficient of row 1. And this number here, A21, is the first coefficient, the first non-zero coefficient of row 2. So this number can be stored into a variable in Octave. So we can actually write this entire expression as R2 equals to R2, and then minus, because we use the opposite, right? The opposite of this coefficient. This coefficient A21 is 2, but we need the opposite because we want to multiply by the opposite of this in order to add the 2 and then get the result of 0 here. So we can put that as A21 divided by A11 times row 1. And same way here, row 3 will be row 3 minus, and then again here is coefficient or entry A11, and this number here is the opposite of entry A31. Okay, so this is A31, A11, R1. We're using R1 to eliminate. So here then 4, row 4 is row 4 minus A41 divided by A11 R1. So that will take care of these 3 coefficients here. And then we switch to column number 2, but then, so we eliminated that. Column number 2, we're going to need to eliminate that. And here are the formulas would be R3. So we're going to, on row 3, we're going to need to eliminate that. At this point, when we are at this point here, we have zeros here, and so we're going to use row 2 to eliminate row 3, this coefficient in row 3, and this one here in row 4. So row 3 will be replaced by row 3, then minus. We divide the entire row 1 by this coefficient here, which at this point is 1, but when we eliminate these first 3, this might not be 1 anymore, it might be something else. So whatever it is, we'll have to divide the entire row 2 by that coefficient, which is A22, and then multiply by the opposite of this number here, which is A32. That's multiplied to row 2 and added to row 3. And row 4 minus A42, A22, row 3. That will take care of these 2, and then finally we need to eliminate this one here. Now at this point we don't know what the coefficient here will be. At the beginning it's 0, right? It's the original, this example here starts with 0, but when we eliminate these 3 and these 2, we may not get 0 here. So whatever that is, we'll do the same process, the similar process we did with column 1 and column 2. So row 4 will be a row 4, and then minus, then we divide the entire row 3 by that coefficient right here, which is A33, and multiply by the opposite of this number, that is A43. And that's multiplied to row 3. Okay, so this is pretty much the elimination algorithm. Now we put that in an algorithm, and for that we need to use loops. Okay, so you can see the pattern here. When we are in column 1, right, column 1, we eliminate these coefficients here, A2, 1, A2, 2, A3, 1, and A4, 1. Then we go to column 2, and then column 3. While we are at column 1, notice that we need to go from row 2 to row 4. When we are in column 2, we go to row 3 to row 4. When we're in column 3, we go just to row 4. That gives us a hint on how we can write the algorithm. Okay. All right, so let's put that in an algorithm. There's an algorithm. There's a loop. The main loop, we can use here the variable j. J will be from 1 all the way to 3, which is the number of variables minus 1. And then while we are each column, then we go to row 2 if j is 1 to 4, or we go from row 3 to row 4 if we're in column 2. So here let's use a variable I to going from, okay, so I'll just put a little symbol here to represent I. So I here starts at 2 and goes all the way to 4. And then here I starts at 3, goes all the way to row 4. Here's 3. And then here I equals to 4. Alright, so the loop would be, I'll just write it here, j going from 1 to 3, that's the number of variables minus 1. And then inside this loop we have another loop going from j plus 1 to n. Okay, so if j is 1, I starts at 2, j is plus 1. If j is 2, I starts at 3, that's j plus 1. If j starts at 3, if j is 3, then I starts at 4, that's again j plus 1. And then those are the two loops, and then inside the loop we use the formula. So here it is. So look at these, the format of these formulas. They are all the same. So it'll be row, you can see this is row 2, 3, 4, that's row I. It'll be a row I minus, and then the coefficient, notice the first number here, 2, 3, 4, that's I, that's the variable I. And then the second index is 1, 1, 1, that's the column j, divided by A, then j, j, and 1, 1. Okay. Times row j. That gives us the formula or the algorithm for the Gaussian elimination. Now we need to put more details here. We're going to see that in just a minute.